All right, today and into tomorrow, we are going to be discussing the scientific revolution. For a discussion today and tomorrow, you're going to need the Bacon and Descartes document activity that you did. You're going to need your textbook notes because we'll be referring to those. And you're also going to need the big reading packet. So take a moment and get those out. Okay, now that you've got all your stuff, some things to think about the scientific revolution. We'll start with the College Board statement here. And so I want you, with your partner, to go ahead and see if you can fill this in. See if you can figure out what these blanks are. Take a couple minutes, see what you can come up with, and then we'll fill them in here in a minute. Okay, I'm assuming we took some time to go ahead and do that. So the new ideas in science, which were based on observation, experimentation, and mathematics, challenged classical views of the cosmos, fancy word for space, nature, and the human body, although folk traditions of knowledge and the universe persisted. So that's a pretty important caveat there. Now I want to take a second and talk about the scientific revolution as a whole. And I think the best way to do that is to kind of look at a timeline here. Look at some of these people we're familiar with. Look at the years these guys were born. This is not completely separate from the Renaissance. Now, the scientific revolutionary ideas really took hold well after what we would consider the Renaissance. But look at this. Look at Machiavelli, Copernicus, and Michelangelo were all about the same age. And so those guys could have sat down and had lunch together, which would have been pretty cool. And then if we look at two of the leading figures of the scientific revolution, Galileo and Newton, Galileo actually died the year Isaac Newton was born. And so these guys are stretched out over a very long time. And so this idea of how revolutionary was the scientific revolution, it was revolutionary in the way it changed, but it wasn't immediate change. A lot of times when I think of revolution, I think of something happening immediate. I think of something happening relatively quickly. The French Rev, the Russian Revolution. Now, there's long-term causes, but the actual revolution is fast. But I think it's important to remember that this happened over a relatively long stretch of time. So now we're going to turn to your Bacon and Descartes document activity, and we're going to talk about those guys' contributions here. So let's start with Bacon and Descartes, and you can use your the notes we've taken, the notes you have from your book, and also the document activity. Sum up Bacon and Descartes individually first. What did each of them contribute? What were their ideas? And then bring them together. What did they do? And we'll come back and have that conversation in a minute. Okay, so let's talk Bacon first. Bacon you should associate with inductive reasoning, from the specific to the general, kind of bigger picture. Inductive reasoning. And he was the earlier of the two. Now Descartes, for his part, he is all about deductive reasoning, from the general to the specific, focusing in. I remember that because Descartes and deductive reasoning. And so Descartes really doubted everything. He said we can't believe anything, that all knowledge is from some sense of experience. We call that empiricism, and that's an important term to know. That's an idea to associate with the scientific revolution. That's empiricism, empiricism, and that's that all knowledge is from some sense of experience, of seeing it, of observing it, of doing it. Now Descartes was a real interesting guy. He was a philosopher, he was a mathematician, he was a scientist, and like I said, he doubted everything. And so he said we need to start with some givens. And the first given that he came up with is what Descartes is most famous for. He said, all right, the first thing that I know is that I'm thinking. And so he said, I think, therefore I am. And so that was a given for him. The only other given that Descartes took as a standard was the existence of God. And this role of religion and God in science is going to be an important part of our conversation as we move through this. And Descartes said it was just a given. One of the earliest scientific thinkers is just a given, that God exists. Another idea that Descartes talked about was this idea of Cartesian duality. And that's the separation of the mind and the body, or the spirit and the body. And those are two separate realms. They're not necessarily integrated. And that was his idea of Cartesian duality. And so now I want you to look specifically at the document activity. And I want you to look at questions number 3, 4, 6, and 7. Those are the ones I want you to focus on now with your partner. Okay, hopefully we talked about that. Now, the key to Bacon and Descartes is what they produced. If we put them together, what did they produce? Go ahead and say it, everybody. Scientific method, I'm hoping you said. Yes, it's the scientific method. It's this idea of experimentation, of making a hypothesis, of experimenting, of seeing your results, and then changing your hypothesis. This ties in with this idea of empiricism. This ties into Descartes' idea of doubting everything, of using observation and experimentation in mathematics. Now, what they were looking for in the scientific revolution and what they're looking for with the scientific method, this is a very important concept, is this idea of universal truths. Universal truths. They're looking for big picture answers. They're looking for answers that are right everywhere under the sun and around the sun and in the universe. These are big universal truths that they're looking for. And in a way, these universal truths, the point of these universal truths was to replace religion, because religion was no longer seen as a universal truth by a lot of people. And so they're looking for answers for big questions. The way they're doing this is they're challenging, they're questioning the authority of the ancients and of religion. Descartes, in a lot of ways, is anti-Aristotle. And so they're calling all these ideas of these ancient scholars and these people who have been accepted as fact for so long into question. And they're also calling religion into question so much, and church beliefs. And this is going to be a very big point, essentially, especially when we get to heliocentric. So the next thing I want to do is I want you to make a timeline. I want you to make a timeline of scientific revolutionary thinkers, the big guys, and what their ideas were, and what they contributed to the scientific revolution. So this is going to be using your notes. So basically you're making a timeline of the scientists of the scientific revolution. Now, one thing to understand is we didn't call them scientists, or they didn't call themselves scientists. That term didn't emerge until the 19th century. They actually called themselves natural philosophers. So now this one's going to take a few minutes here, probably 3-4 minutes. Make a timeline of the scientists, of the natural philosophers of the scientific revolution and what their contributions were. Okay, so this all starts with Copernicus. It starts with the Copernican revolution. No pun intended, because it's spinning. So anyway, on the left here, you see the Ptolemaic universe. This is with the Earth at the center of the universe, and everything revolving around it. This was the system that had been believed since Hellenistic times. And the church supported this view because it was supported by the Bible, that the sun stood still, and that was demonstration of God's power. So we start with Copernicus. He is the first one really to develop the heliocentric theory. But he didn't publish about it until his deathbed, until he was until he was on his way out. And the big question there is why? Why didn't he? It's not just a hypothetical question. Right, because he feared the repercussions of the church, because he knew the church was against this. And so he was afraid to publish. He didn't want to get in trouble. Copernicus, actually Polish, so you Poles out there, Copernicus is the Latinized version of his name, Nikolai Copernicus. The next couple guys that are important in our timeline are both continentals, a Danish and a German, a Dane, excuse me, not a Danish, that'd be delicious, and a German. Tycho Brahe, he developed the heliocentric model. He developed a more exact model about the planets moving around the sun. Now, he didn't get it exactly right because he still said the sun moved around a fixed Earth, but he kind of took the next step. Kepler is the next guy. I think about Kepler. He put the mathematics into the heliocentric theory. He showed that the planets moved in ellipses and not in perfect circles. And he demonstrated these things mathematically. Now, it's important to think about why Brahe and Kepler weren't afraid of the church on this, weren't afraid of publishing, and that has to do with their religion. They were both Protestant, and so they weren't concerned about this. So these are the big steps that are coming through as far as our views. The next guy who really takes the next big step is Galileo. And he did a lot. He furthered the heliocentric theory. He developed a theory of gravity, although he didn't actually know what gravity was. He just showed that some force was acting on everything the same way. He actually did it dropping cannonballs off the Leaning Tower of Pisa, but it was just the Tower of Pisa at the time. He developed ideas about inertia. He developed a better telescope. He didn't invent it, but he developed a better one that allowed him to observe the phases of the moon. And he was able to kind of get away with it for a while because he was friends with the Pope. He actually was a confidant, a close friend. They wrote to each other. But eventually, despite repeated warnings, he continued to publish, and eventually he was called before the Inquisition, and he was forced to recant his ideas. And this is really important because he did it. He was an old man at the time, and he was going to be placed under house arrest for the rest of his life. But the church was still wielding power and influence and forced him to sign a document saying that everything that he published was wrong, everything that he talked about the heliocentric, everything that would be considered heresy, heretical ideas. And according to popular legend, though, as he signed that recantation, as he affixed his name to that, he looked up and he said, "And yet it moves," saying, you can make me sign this, but it's not going to change the fact that it still moves. And so I think this is a good time to talk about why is it so important to the church that they get this right? Why is it so important that they not be proved wrong? And that's an important idea to discuss. So take a minute with your partner and talk about that. Did we get it? The church was afraid because if they were wrong on this, what else could they be wrong about? The Reformation is hitting its height at this point, one of its heights, I should say, and they're just being besieged by all sides, and they don't want another spiritual and intellectual attack. And so it's really important that they hold their ground on this. Now, after Galileo, we get Bacon, Descartes, we get the formation of the Royal Societies in London and Paris that we're going to talk about later. But these guys are all reaching towards one pinnacle, towards one guy. And that is, of course, Sir Isaac Newton, Sir Fig Newton, if you will. And one of the things I think is interesting is so far all of these guys, Copernicus, Brahe, Kepler, Galileo, they are all working in what field, in what scientific field? Yeah, astronomy. They're all working in these big picture ideas, these huge universal ideas that really don't affect people's everyday lives. They're not, the idea of what circles around what, I suppose, is vaguely relevant, but it still doesn't change what time you wake up because it gets light outside and what time you go to bed when it gets dark outside. Now, Newton is going to do a lot in the field of astronomy, but he's also going to take other steps. He does laws of motion. You see him there in the lower left. Inertia, force equals mass times acceleration. For every action, there's an opposite and equal reaction. You don't need to know those specifically. It's not a physics class. He does work with optics, with light, with vision. He does a lot of work with gravity, as you can see with his equations there. He kind of finalizes the astronomical studies, the celestial studies of all the guys coming before them. The book he writes, the Natural Philosophies of Mathematics, it's called the Principia. The Natural Philosophies Principle of Mathematics. The Mathematical Principles of Natural Philosophy. I knew I would get it sooner or later. It's just called the Principia. That's all anybody ever calls it. And this is the pinnacle of the scientific revolution. This brings together the previous practically century of scientific thought. And one of the really important things to understand is the universe that Newton described. What was it like? I want you to think about this. How did he describe the universe? How did he describe the way it worked? All of these things, his laws, which would be universal laws. How did he describe the universe? So think about that first. It might help to think about, so he's making all these universal laws, and he's describing, and all of them are describing, a very orderly universe, a very mathematical universe, one that can be relatively simply explained by these universal laws. And he actually used a pretty simple metaphor to describe the universe. The most precise device that people were familiar with at the time that was incredibly intricate was a clock. It takes all kinds of gears and levers working in perfect synchronization for a clock to work. And so he described the universe like a clock. All these things working in harmonious order together. And that is how the universe worked. They're all following these laws. Now, the key for Newton was that he believed that God was the clockmaker. That there was somebody who put all of this in motion, who created this orderly, harmonious universe and set it in motion. But then to Newton, the creator, whoever this being was, stepped back and just let it run. A lot of times Newton is considered the first deist, D-E-I-S-T. That's an important idea. These people aren't atheists, but they're not necessarily aligned with a church or a tradition religion. They believe that there is a supreme being, but they believe in natural laws and universal laws that the supreme being kind of set in order. I want to bring up one other idea about Newton before we move on here. Newton also developed calculus. He's the first guy to develop, one of the first guys to develop calculus. But here's the real kicker. Newton's calculus was wrong. He got it wrong. He and I have a lot in common as far as calculus goes that way. The way he developed it wasn't correct. But when he developed it, he was already a member of the Royal Academy. He had already published many things, and he was famous. Meanwhile, there's a guy on the continent, this guy named Leibniz, who developed a system of calculus that was actually accurate. It worked. But nobody listened to him because who is Leibniz from the continent? Who is this guy? And Newton had the full backing of the Royal Academy. And so I think it's interesting how nationalism, how clout, how influence can play a role even in scientific development. Before we move on, I want you to take a moment. We talked about a lot from this timeline, these natural philosophers, universal truths, religion. Take a moment and kind of bring this all together. What is going on here in the scientific revolution before we move on to some more specific ideas? Okay. Next, I want to take a look at these maps. These maps demonstrate in 1500 and in 1700 the news travel time to Venice in weeks. So those numbers going out are how long it takes for news to get to Venice, or from Venice for that matter. So the larger the number, those are the weeks involved in how far it gets. So take a moment and look at these. Try to figure out, make sure you understand what the maps are demonstrating, and then answer the questions there. What caused the increased speed? And more importantly, what impact would this increased speed have on Europe? So take a couple minutes and talk about that with your partner. Oh, you're back. Sorry. Just taking a couple notes here. So next we're going to go to your big packet, the readings on the scientific revolution. So the one you did in class the other day, you started in class the other day. So take that out. There's going to be a lot more pausing and stopping and starting here from here on out. So the next question I want to talk about is the witchcraft one, the impact of witchcraft on the scientific revolution. So go ahead and talk about what did these new ideas, how did these new concepts, how did this new theory of proof, what impact did that have on witchcraft? So base it on that reading. You can base it on the College Board statement, if you will, and we'll get to another one later. So what impact did the scientific revolution have on the belief of witchcraft? Okay, the next one, we're going to the long section in there, the quantification of Europe. That's from a book by Alfred Crosby, a pretty famous book about how the West started using numbers to describe things, and that facilitated a lot of changes. He goes into everything from double entry bookkeeping to musical notations and to the scientific measurements. So take a moment and talk about the quantification of Europe, everything from the Copernican revolutions and the cute and scary space kittens that were out of the bag, to all of those other notation ideas that he brings up. So talk about that big middle section of your reading for a moment. All right, now we're going to take a look at a couple paintings that were in your reading also. These are by a guy named Vermeer. And what I want you to do is, using these paintings, tie them into the scientific revolution. How did these paintings reflect the progress of the scientific revolution? Now, to answer this, you probably first want to talk about how the age of exploration and the scientific revolution go together, because that's an important theme here in both of these paintings. So using both of these, go ahead and talk about how did the age of exploration and the scientific revolution go together? That's the first question. And then the next one is, how do these paintings reflect the progress of the scientific revolution? So go ahead and do that. All right, next, we have a very big picture question. I want you to start with the Middle Ages. Think about what the disincentive for science in the Middle Ages was. And then I want you to describe the intellectual continuum from the Renaissance to the scientific revolution. So we go from the disincentive of science in the Middle Ages to the Renaissance, the Reformation, the Age of Exploration, and then to the scientific revolution. What changes intellectually? What happens? What changes happen that facilitate this intellectual change that's happening over the course of centuries? This is a tough, big picture question. See what you can come up with. I actually love this discussion because if we go back to our disincentive of science in the Middle Ages, it said people didn't need to question anything because they always had their answer, and it was the church. And if we think about the Middle Ages even more, there was no belief in progress. There was no belief that things were going to get better. And so they didn't look for answers. They didn't have any desire to change things because they didn't think they were going to be any better. But then as we get through the Renaissance, the Reformation, the Age of Exploration, all kinds of things change, and hopefully that was the basis of the conversation you just had. And so now all of a sudden there is incentive for science, there is incentive for questioning, there is incentive to looking beyond just what you have now. This is that belief in progress that we talked about, started in the early 18th century. And this is just such a cool big picture idea that you should be really proud of yourselves that you can get some idea of this huge scope of history I hope you appreciate what you know, because it's pretty darn impressive, kids. Now, the next idea that we're going to look at is the role of the academies. And so if you would go to that section of your reading, please. I was reading on the English academies and then on the French academies as well. And what I want you to do, just take a minute and look at this engraving. I think it kind of sums a lot of things up. So take a look at the engraving and read the little reading that goes along with it here. Okay, so the question I want you to talk about is, what was the role of the academies in the scientific revolution? What did they represent? How did they help facilitate the scientific revolution? Those are some really big ideas here. So what role did the academies play? How did they, or excuse me, what did they represent? And how did they help facilitate the scientific revolution? Role, what did they represent? How did they help facilitate? Go ahead. I think one of the helpful things to do here would be from your textbook notes to look at primary source 16.2, the one about the silkworms and the cocoons. I think that's a worthwhile conversation to have about the academies also. So go ahead and take a minute and talk about that. You'll have to dig through your notes a little bit and find it. Look, skeletons. Okay, next it's time for a big question, and you had to know this was coming if you gave it any thought. Did women have a scientific revolution? Using those multiple readings that you had, I want you to defend your statement. Did they have a scientific revolution? We talked about if women had a Renaissance. We talked about if they had a Reformation. We said no, they didn't have a Renaissance. We said a Reformation happened around them or it happened to them. So now the next big intellectual movement here, did women have a scientific revolution? And use specifics from your reading. Go ahead. Okay, hopefully you talked about how women were excluded from universities, but there was still a handful of women that played a role. German women, some specific women, they were excluded from academies. Men actually used the scientific revolution to keep women down, to say that nature suited them for motherhood and nothing else. So as far as I think, the way I think about it is, definitely if we look at Cavendish and Winckelmann, I say a few women did have a scientific revolution, but women did not. So that's the way I view it. If we say, did women have a scientific revolution? I'd say no, but a few women did. But generally speaking, they did not. This is just kind of an interesting picture here. I like this. The College Board uses it all the time. It's called an experiment on a bird in the air pump. And he's making a vacuum in there and going to suck all the air out on that bird. And this is kind of showing, a public experiment. And you can look at, the one young girl is looking away while it's being explained, and the boys are all taking it very seriously, except for this couple over here that are more interested in each other. And there's light coming in, shining in on the room, but it's just kind of a famous picture that is associated with the scientific revolution. It's from 1768, so kind of like as these ideas are being pushed into the forefront of acceptance. So the next question I want to focus on, and this is actually, there's 3 questions left, but this is the last one that's directly related to science. And that is the question, how complete was the scientific revolution? If we want to argue that the scientific revolution was the largest mentality shift in human history, which we'll argue in a few days here, or argue against, is that true? How complete was the scientific revolution? Take a moment and talk about that. Okay, I will refer to the College Board for their thoughts on this. Alchemy and astronomy continue to appeal to elites and some natural philosophers, in part because they shared with the new science the notion of predictable and knowable universe. In the oral culture of peasants, a belief that the cosmos was governed by divine and demonic forces persisted. So if we look back all the way to our beginning, This idea that there is folk traditions of knowledge and universe persisting, there's still a caveat as we get through the scientific revolution. That even some of the naturalists, Newton spent his spare time doing alchemy, trying to turn inert metals like alchemy into lead. He was trying to find a universal law that would do that. So I think that's a pretty interesting perspective on the completeness of the scientific revolution. So now, some of the last aspects that we're going to talk about. If you remember, during our big 18th century culture unit, we talked about law, and we talked about the courts and what was accepted and what wasn't. And so I want you right now to talk about what impacted the scientific revolution, more accurately, its new questioning of authority, its new requirement for truth. What did that have on the field of law and of courts? What is that going to do? What is the scientific revolution going to have on the use of torture for getting evidence? So take a moment and talk about that. Think about the scientific method and what impact that's going to have on courts and legal proceedings. And the last question for us to look at is the impact of scientific revolution on universities. These universities were the traditional ways of thinking. They were houses of the traditional ways of thinking, and a lot of these guys were coming from, most of these guys were coming from outside of the universities. So what's the role of universities in this scientific method, scientific revolution? So now I'm going to go back to the original big picture statement here. New ideas in science based on observation, experimentation, and mathematics challenge traditional views of the cosmos, nature, and human body, although folk tradition of knowledge in the universe persisted. Tie it together. We talked about a lot of things. See if you can use specifics to defend all the different parts of this statement. See if you can bring all of these scientific revolutionary ideas together. Hopefully this helped clear up a lot of these ideas of the scientific revolution. So I will leave you with that challenge to try to bring it all together.